Let's go over a couple of examples for this week's discussion quiz. In question 1, we're asked to compute the differential for the function y is equal to arc sine of 5x cubed plus 7. Essentially, we're taking the derivative, but instead of writing it as dy dx, we put the dx on the other side of the equation. So automatically, I know that a and b cannot be the correct answers. It's got to be either c or d. So let's differentiate this function. I'm going to note that it is a composition of two functions, and therefore I'd like to use the chain rule. But in doing so, I'm going to write down that the derivative of y with respect to x is whatever the derivative of arc sine is. The rule for that is 1 divided by the square root of 1 minus whatever's composed in the function squared. And what's composed in the function is 5x cubed plus 7. By the chain rule, you have to multiply by the derivative of the inside, which the 7 goes to 0. When you bring down the 3, you get 15x squared. And that's the derivative, but as a differential, we can essentially treat this as a fraction and cross-multiply the dx over here. We can put this 15x squared into the numerator. We can multiply that over. And if we do those two things, dy is equal to 15x squared divided by the square root of 1 minus the quantity 5x cubed plus 7 squared, all times dx at the very end. And hopefully that is one of the choices, and that appears to be C. So it looks like C is the correct answer, and I'll put capital C in the box. Question 2 is a related rates problem. It says this circle, the radius of it is decreasing at a rate of 5 inches per second. Can we determine the rate at which the area of the circle is changing once the radius reaches a length of 10 inches? Okay, so we're given the formula for the area of a circle, and in here I'm going to label the radius. So here's one of my variables, r. R is the radius of the circle, and the units in this are in inches. A is going to be the area of the circle, and that is going to be in inches squared. Once you've defined your variables, here I put them in the picture and off to the side, I'm going to look at what the rates of these are with respect to time. Like, what is dr dt? That is the rate at which the radius is changing. And in fact, we're told that this is decreasing at a rate of 5 inches per second. We have to interpret that as decreasing means negative and then 5 for the number. So that's the rate for the derivative of the radius. Now, what is dA dt? Well, we don't know what this is equal to. In fact, this is what we're trying to solve for when the radius reaches 10 inches. So that's our goal. Given this piece of information, what is this value equal to when r is equal to 10 inches? I'm going to note that the rate of change, this was 5 inches per second. The answer here should be square inches per second. So how do we find this thing? What we do is we take the derivative of this equation with respect to time. So that is, you're going to do d dt on both sides of this equation. And the equation is the area on one side and then pi r squared on the other. Starting on the left, what is the derivative of a with respect to time? That is simply dA dt. On the other side of the equation was the derivative of pi r squared. Pi is a constant, r is a variable. You bring down the 2, multiply it to the pi, copy down the radius, and then by the chain rule, you have to multiply by the derivative of the radius with respect to time. Like, this is perfect. We're looking to solve for this, and we know what r is. R should be equal to 10, and we know what dr dt is. That should be equal to this. So we can simply just plug those numbers in to solve for dA dt. dA dt is equal to 2 times pi times the radius, which is 10, times dr dt, which is negative 5. And the units will be inches squared per second. I'll continue that work over here. Maybe if I simplify that a little bit, dA dt is, okay, so that's negative 50, negative 100 pi. inches squared per second. I would be careful how this answer is interpreted because it asks how is the area changing. This negative means that the area is decreasing at a rate of 100 pi inches squared per second.